First off, a little bit about Partel. We're an Irish company. We're active in the UK, Europe, and North American market. We're founded by architects and engineers with a really keen interest in passive house design and building physics. We're actively involved in R&D, manufacturing, distribution, and offer a really thorough technical consultancy and sales. In terms of ventilation, we are the official distributors of Lunas and Vasco ventilation systems. So the idea with this slide is that we try to get people to recognize the importance of ventilation. So as humans, we've got 5 basic needs. It's air, food, water, shelter, comfort, and sleep. Me at the end of that presentation, maybe. But really, air quality, it's that important. It's right up there, but we don't always consider it like that. So it's okay to be more detailed and to ask for more information about your ventilation system and kind of what we want it to do. So the basic idea with our ventilation system is that it improves our air quality by mixing fresh air from the exterior with the stale air from the outside or the inside. So the rate of exchange or ventilation is what determines our final indoor air quality. But overall, we want it to be able to remove our CO2, supply oxygen, reduce VOCs, PM10 and 2.5. It's critical that it can save energy. It can also help with dust and pollen. And one of the key factors is that it can control relative humidity or water vapor. We have all of our ventilation set to try to get the building into what we call the optimum zone. So that's relative humidity between 40 and 60%. And that's an area where it's very hard for bacteria, viruses, fungi, mites, respiratory infections, all of those bad things find it very hard to exist in that relative humidity percentage. So that's a key target, if you like. And in a year where we've had a renewed or a real focus on indoor air quality, it's really down to COVID. And I think everyone has seen an awareness about the necessity or the importance of fresh air. I know we found that in inquiries that places that have higher occupancy like schools, offices are really keenly aware of the exchange rate and probably also aware that recirculation is not an acceptable way to deal with good quality air. So just a few facts on ventilation. We tend to get inquiries where people will seek to install a ventilation system and maybe expect that will deal with all issues. So some key things to be aware of. Thermal bridging can create localized issues where we can still see mold. So in a house that is otherwise well built and has good quality air, if the thermal bridging allows a cold enough part in the house, it's often close to a window or a door, the air can cool enough to allow condensation. Basically, the water vapor that's held in the indoor air, the colder the temperature, the lower the ability or the smaller the volume of water vapor it can hold. They're all kind of relatively connected, I guess, air tightness, dew point, and breathability. I'll show a slide on that in a moment, but really the other thing is that ventilation systems, they work equally well in breathable or non-breathable construction. So really it's independent of the air tightness. We should absolutely have a good quality ventilation system in all dwellings. The term breathability is, in my opinion, misunderstood by the vast majority of people in terms of construction or in building. It always refers or should mean water vapor, not air. So it can be okay for a building to be airtight and breathable. It can be airtight and not breathable. So the breathable fabric doesn't actually deal with fresh air. It's more about how the walls can dry. So when we go back to I suppose, a visualization of what breathability means, it kind of a figure. So an ST value is the equivalent, it measures the breathability of a material relative to the equivalent thickness of air. So the more breathable the product, the lower the ST value. If it's vapor tight, it's less breathable. On the real or key changes for NZEB for Part F, when our air permeability, I suppose overall our air permeability has been reduced to 5. So we need to build below 5 meters cubed per hour per meter squared. The biggest change is that it's only possible to ventilate with natural ventilation if your air permeability is between 3 and 5. If your air changes are below 3, it means we have to have a mechanical ventilation system. Following on from that, all ventilation systems must be validated by an independent, competent person who is certified by NSAI or equivalent. And lastly, there's a renewed focus on the efficiency of these systems. So it's moved towards a BER with an A2, with the, I suppose, changes to the MP EPC and the MPCP. So a real focus on lower energy consumption and reduce carbon impact. So how do we get to that NZEB compliant ventilation system? And I guess what this is, it's the second pass-fail component of a new construction. So it's a blower door test, but it's now also the ventilation validation. So there's a couple of steps in it. The design of the system should be competent. There is a training course where people can, freely train. It's operated by Mozart and run with in connection with WWETB. The installer of the system also needs to be competent. So it is advised that the installers also attend that course. And finally, the validation. So the validator can check for compliance with Part F and will also check for flow rates. So that's every house that needs to have that carried out. There's 3 routes towards compliance. So we've got continuous mechanical extract ventilation, that's CMEV. You will see it referenced occasionally as centralized MEV or CMEV as well. A little bit of confusion in the regs, but they have clarified that it is CMEV is continuous mechanical extract ventilation. So that can be delivered in a centralized or decentralized way. It's often known as a demand controlled system. We can also do heat recovery. That can be in the form of, again, decentralized or centralized. And lastly, we have natural ventilation. I'll show how each of those systems work in a minute. Just a little look at kind of how we expect heat recovery to evolve in our region or the ventilation market. So we've taken a look at Germany as the most developed ventilation market worldwide, and it's really quite interesting to see how it's been changing over the last 10 years. But currently, decentralized heat recovery accounts for about 30% of all ventilation. Extract systems is a CMEV system. Again, they're about 30%, and we have centralized heat recovery 22%, and other, which could be our natural systems, at 18%. So overall, we're seeing a real kind of growth area in this decentralized market. And the reasons for that is much lower running costs, very uncomplicated and easy installation, can always be inspected. We don't need to be able to see all the ducting, or there is no ducting. And we also don't need to drop ceilings to build in these systems. They are suitable for retrofit, and that should be, a really significant part of our of the next kind of 10 years, where we try to bring buildings up to code. A little about Lunis. They're 60 years old. They account for overall 30% of the entire German ventilation market. They have a 50% share of all decentralized heat recovery, and they are really the founder of the modern decentralized heat recovery units. They're active worldwide with a current turnover of about 40 million, and have just completed what they say is the largest domestic ventilation factory in the world. We have seen it. It's really, really high tech, impressive, and significant testing and development capacity within that factory. We also represent Vasco. Vasco are a centralized manufacturer. They're known for their silent ventilation systems, but also carry passive house certified systems and a really interesting, unique ducting system. It's a Vasco's own system, but it's assembled in parts, and What it actually means is that you never cut the ventilation ducting. They always can extend or slide and be connected to meet the overall length. So really we're looking at less room for error with install, and that's a key factor with ventilation ducting generally. So how do we work on compliance with natural ventilation? So this is how it works and how it looks. We take a typical 130 square meter semi-detached house. The air permeability to qualify for natural ventilation is 5 air changes, between 5 and 3. This house is getting known as the Swiss cheese house. What it means is we've got intermittent extract fans. So these are fans that are activated by the user and will typically have an overrun of 6 to 15 minutes. They then in practice have an open vent. That's a calculated figure. So in this house, it could mean 12 permanently open 100 millimeter vents. The reality of this type of system is that we don't necessarily have a draw or a way to force this fresh air in. So the amount of fresh air we get can be dependent on wind, outside conditions, or shelter. This could be the reality of what a naturally ventilated home looks like. If we've got wind from this side, we will have an oversupply of fresh air in the open air inlets. Because of the low quality systems that people tend to use in natural ventilation, some of the cheaper decentralized extract systems, the wind can easily overpower the fan. What that means on the opposite side of the house is that we actually get no ventilation on this side of the house. So it's a really uncertain way to deal with fresh air. We actually yesterday installed in a recently complete building, totally compliant with natural ventilation, but we had to upgrade their system to a Lunas CMEV system. They were already experiencing mold and it's a large, well-built housing estate. So it's basically been proven not to work, and it should be a real question mark. The other thing is that the suggested air tightness of between 3 and 5 is something that's very hard to design for. It's not easy to say I want to achieve 3.5. So while it's possible in the regs, it's really not recommended. So to look at CMEV and heat recovery, the general situation for the regulations is that we design either based on floor area or on occupancy. And it's the larger of the two. So for smaller dwellings, the ventilation rate will be determined by occupancy. If the bigger building is maybe over 140 square meters or 130, it can be based on floor area. There is also a check on a boost rate, and again, it's kind of a which figure is larger, and we build in an additional 25% over the general ventilation rate, and that's a design capacity check. So we want to be sure that the ventilation system designed is not working at its maximum. So to show how the CMEV systems work, again, they can be centralized or decentralized. So it looks a little bit like the naturally ventilated house, but it has a significant difference. The extract fans are permanently active. So they are always on, but they're also, if it's the Luna Silvento, an incredibly powerful fan. So something that can deal with the outside conditions easily. In addition to the fixed running costs, the systems can be activated by movement, humidity, time, temperature, and as of the end of this month, CO2 and VOCs. The air inlet is used to balance the air that is taken out by these smart extract fans. So really, the extract fans depressurize the house and force a regulated amount of fresh air through the Lunas ALD. The Lunas Silvento EC, it's an electronically controlled fan. It can deal with a pressure difference of about 400 PA, so one of the most powerful fans on the market, but also one of the quietest. So you will find if you need to inspect a Luna Silvento, you'll need to remove the cover if you want to see that the fan is, or to be able to see it, because you won't hear it at its up to half of its operating speed. Lunas have been able to introduce visible warning and running indicators to match the changes in NZEB. There is now a requirement that all ventilation systems have a visible running or not running. So it's no longer enough just to show a fault. We also need to show that the fan is running correctly. The ALD, or air inlets for Lunas, are a really clever modern day hole in the wall. They're not a very expensive unit, but they work really, really well. They can deliver up to 65 dB of sound protection through these star-shaped acoustic attenuators. But we've also built in wind pressure reduction. So it means that we're never looking at an oversupply from the ventilation systems. The next slide, I wanted to have I guess, a little comment about the difference in quality in a fully evolved system like Lunas and what people have come to know as a decentralized mechanical extract system from the UK or Ireland. The fans that people might use or have been used to using are essentially 20-year-old technology. It's exactly the fan that Lunas have used and supplied 20 years ago. So if you step back and think about that, what's happened in 20 years? We've got the internet, smartphones, huge changes in climate change. For Lunas as a company, they've been developing new systems every year for 20 years. So it's a dramatically different system. So just important to be aware of the differences with that. I wanted to look at heat recovery and how that works. So again, decentralized and centralized. Probably the biggest change in ventilation happened in 2011 when Lunas developed the E² system. The E260 is the most recent version of that. The 60 stands for Lunas's age or its birthday. But again, like the other fans, they've evolved quite a lot. So this fan can now, it's the only one that has an integrated Class S1 wind protection integrated to the fan. So quite different. Again, they're really, really low running costs. So from 56 cent per annum at its lowest speeds. How does it work? Again, we're looking at the same type of house. The E260 fan always works in pairs. So while we have one fan extracting here, its partner is supplying air on the opposite side. So every 70 seconds, the fan changes direction, and it's in that way that it has a push-pull continuous fresh air supply. The bathroom version or the wet room version is EGO. That has 2 miniature fans built in. If we've got, let's say, like a landlocked room where there isn't an exterior wall to mount the EGO fan, we can use a Solvento fan, the same fan from the demand control system. Looking at the different options, there is some variation in that, I guess. We have the original E², so if you like a classic or a proven fan, the E260, which has increased volume, wind protection. That's the main fan we work on for the UK and Ireland. But there is short versions available as well, down as low as 360 millimeters if your existing wall is quite small. The EGO, you can see it here with 2 small miniature fans. So it's essentially 2 E260s built into one duct, and it's always through one exterior duct. Lunas have also developed the next fan. These are a larger semi-centralized unit. They have a single exit point through an exterior wall. And again, like the EGO or like a larger rear EGO, can do supply and extract continuously to opposite sides. We've used these fans in schools, in office spaces, but generally open plan areas, that's where they're most suited to. It is possible to conceal the Lunas fans in exterior walls, easiest if we're using external wall insulation. So we connect the pipe for the E260 here. It fits into this Lunatherm element and can be completely hidden in the reveal of the window. This was an interesting, I guess, a comparison of costs on standard extract fans and trickle vents versus a heat recovery and Solvento system. It's for an assisted living project or like a college project, but yeah, some really significant long-term changes. So the Solvento fans are tested or have a 30-year age-tested motor. So it's a really huge kind of saving in replacement costs. So a lot of the costs with ventilation, certainly in in rented accommodation is maintenance. So one of the big advantages you can get by using a better quality system is really just a change or a clean of a filter at the end of every year. We are also finding that lots of councils and social houses are having real and tangible issues with air quality. So the cost of an air quality monitor is dropping significantly. They're really easy to get your hands on, and tenants are now aware of their rights in regard to air quality. So the system is €100. It's easy to check if the house is able to provide you with a good quality fresh air. So that running cost, not just based on the health issues, but also what's the maintenance cost if your house has got a continuous mold issue, and that is something that people experience on a regular basis. To look at how centralized systems work and what's available, from Vasco, we have two types of system. The known centralized residential systems, they deal with air volumes from 150 to 500 cubic meters of air per hour. And in about 1 to 2 months' time, there will be a larger commercial space unit available. It'll be ceiling mounted or floor mounted, but can do up to 2,600 cubic meters of air per hour. This unit is really targeted towards schools and medium-sized office space. Generally, with the centralized system, we're looking at, or ideally looking at, a unit mounted inside the envelope of, or the insulation envelope of the house. They can be fitted in attic spaces, but that does require a little bit more detail. But the general principle is we're taking warm or humid air continuously from wet rooms, we're cycling it through a heat exchanger and providing clean, fresh air to the habitable rooms. The qualification or the amount of air that we decide to bring in is based on the same standards for decentralized. So to look a little closer at ducted systems and to talk about the design, Jeff may touch on this later, but there's not a great deal of evidence to suggest that the centralized systems being installed today are being designed thoroughly, being installed, and being commissioned. So it's critically important that people seek and ask for a quality design that shows the air, the final air supply and air extract from all rooms, but also what is the type of ducting being used? How is it going to achieve that? Will what's installed on site match the drawings or the technical drawings provided? There's lots of options with ventilation ducting, and you'll see maybe a little bit less of this type of flat pack ducting now. I would say this is the most popular, the semi-rigid. This is the Vasco system. There's pros and cons to each one, but really the onus is on the specifier to ensure that the design is good enough. After that, thankfully, with the verification process, we do have an external body that will assess and approve or fail the ventilation system. It's worth bearing in mind the pass-fail rate for that, I think, will be quite interesting. It's onerous. So if we kind of go ahead and use maybe too long of a ducting run with a semi-rigid or too many bends in this type of a duct, you won't be able to achieve the final airflows that you need. So really, really important that people adhere to the design. So how do we get things right in ventilation? So we need to make space for the system. Ideally, it's on the north face, and the extract points should be away from windows or patios. So kind of despite what people might say, centralized systems do make a little bit of noise where they exit. The better the quality of the design, the quieter the system. And I think this point is really key. Plan the system early to avoid complications. And that is something that just doesn't happen at the moment. So it's really, is there a plant room available in the house? Is it well located? If the plant room is centrally located and we've got, relatively uncomplicated duct runs, it makes it a lot or increases the chances of a good quality system and a good quality install. If somebody chooses aesthetics and decides to locate the fan in the corner of a building, it means much longer duct runs to everything, and again, less chance of the final install being correct. I would always ask this question, or suggest that people ask that of the ducting: can it be cleaned? Is it airtight? The first question tends to get answered with, well, the shape of the duct, or there's a special cover, or type of a finish on the duct that stops it being, or any dirt adhering to it. But I think practically most people will say, I want the option to be able to clean that. Things may not be perfect. The extract may take some grease. It may take some moisture. After that, some dust might start to accumulate. So it absolutely makes sense to allow for cleaning in your ventilation system. On the subject of filters, they're a minimum recommendation that they're cleaned or replaced every 12 months. For decentralized, it tends to be a clean. Your filters should last you about 10 years. For centralized, it's generally a replacement. It's definitely not a bad idea to shorten that time frame from 12 months. It's also one of the reasons why people like to have the centralized system located inside the building in a utility, in a hot press. If it's there, you're more likely to be okay to change the filter. Going back to the rented accommodation, people do build it in these days as a part of the service check. So when the boiler is being checked, the filters for the ventilation system will also be replaced or cleaned. On the subject of sound, kind of how we deal with that. So decentralized systems, they always achieve their designed sound levels because there is no ducting. So it's a really kind of key factor. And I would say generally with decentralized systems, you'll always achieve what is stated on the data sheet. You don't have the variability of the ducting. In centralized systems, you should certainly consider, is there silencers, crosstalks, depending on the type of ducting you're using? And yeah, is there more bends than was planned? What is the final sound that you're going to end up with? So again, just be really careful with the ducting supply. That makes a huge difference on the final sound levels of your system. So just to look through a couple of examples, this is a Dunleary Rathdown Council. It's a Lunas heat recovery system for senior citizens. They wanted an uncomplicated automatic system. So they use a combination of E-GOs, you can see the little covers there, and E2s here and here throughout the development. You will also see the Lunas demand control system, or the CMEV system, used in housing estates. It's becoming quite a popular solution. You can see the ALD unit located here. So this development in Dublin used Solvento and ALDs, a really uncomplicated, simple system. This is a nice example of the old and the new. We used the E2 and E-GO, and the building was part of a larger upgrade to go from a G to A3 rating. They also integrated airtightness, different types of measures, using some wood fiber for the older building, but overall a really high quality install, and interesting to see that Lunas can be used in the new and the old equally. We'll often get asked, can Lunas be used in a certified passive house? It's uncomplicated. There is a number of examples of that. And just on the office space, this was, again, a Leopardstown Council project where they decided to install heat recovery to a refurbished open plan office space over 2 floors. I thought it was a really good example of a ventilation system making genuine space heating savings. So 76%. They used 10 Next systems, and an overall running cost of 41 cents per day. So just to recap a little, kind of what you get from Partel, it's always a system, product warranty, insurance backed. We carry design indemnity. There's a lot of product testing from the external. So we're about to finish BBA with Lunas. The demand control system is tested in BRE together with the Fraunhofer DIBT, lots of external testing on the systems. We are working with another institute to carry out some monitoring over a 12-month period of a ventilation system, and it'll be published as a final detailed report, if you like, validating the systems. So thanks everyone for the time. I'd say I'm a little ahead of schedule. we will have the final plenary quite soon. The plan is that we will start at 2 o'clock, so it gives people a chance to have a coffee or lunch, and we'll be welcoming Jeff Colley. So yeah, thanks to everyone. We'll start at 2. You can leave the connection open to Zoom and just come back at 2. Thank you.
Thanks, Hugh. That was really good. I always come away from your stuff figuring out what I want to put into my own house.
I can help with that, yeah.
It was dangerous one time. I did a dike and one I ended up with a dike and heat pump. So there you go. Yeah, no, really good information as always. Fantastic work. So just as you mentioned, 2 o'clock, we'll have the final plenary session. Any of the questions that have been put through as part of this presentation, Hugh will address those in the later section, and then all of the companies that are involved, Partel, Core, Dyke, and Northern and Harmony, will do just a general recap, a very quick recap of what's gone on to date. But yeah, we look forward to seeing everybody back at 2 o'clock, and I know certainly Jeff has some really excellent information he's looking forward to share with everybody as well. So we'll see you all very shortly. Okay, thank you.
Cheers.